July 5, 2018, an unprecedented event took place in northern Siberia, along the coast of the Arctic Ocean, which has triggered all the alarms. A heat wave made temperatures soar 25 degrees Celsius above normal on those summer days to a record-breaking temperature of 33 degrees Celsius. That heat wave spread all over those northern latitudes, from Canada through Greenland, the Scandinavian countries, and Russia, making the temperatures rise to record highs. On 25 May 2017, the Larsen C ice shelf rift completed its path through the ice. As a consequence, a huge iceberg of 5,800 square kilometers calved away from the ice shelf. This enormous iceberg was one of the biggest ever recorded. But this wasn't an isolated case. On 12 July 2012, for the first time since we started keeping satellite records 30 years ago, 97% of the frozen surface of Greenland started to thaw. Even in the central area of the huge island, at an altitude of more than 2,000 meters, signs of thawing have been detected, something that hadn't happened since 1889. Maybe just a few millimeters of the huge ice sheet had melted. However, the fact that it happened for the first time ever shocked the whole international scientific community. All these events corroborate a fact that has been observed for more than 20 years. The impact and speed of climate change in the polar regions is much greater than in the rest of the world. The effects of climate change are already well known. More extreme weather events like hurricanes, tornadoes, storms, or heat waves, rises in the sea level, virus mutations and new diseases, etc. The very first effects have already been observed. But among all the effects of climate change, one in particular is especially worrying: the melting of the poles. The melting of the poles is one of the most dangerous consequences of climate change because it leads to consequences on a global scale. Besides which, there is a very disturbing and little-known fact known as the amplification effect. The more ice that is lost at the poles, the faster they thaw afterwards in dangerous geometric progression.
So while you have a clean, dry snow cover, it will reflect about 90% of all the solar energy back to space. So only 10% is heating up the surface. If you take away that snow and replace it with soil, it's 90% of the energy that goes into the surface of the planet, warming it, and only 10% is disappearing back to space. So that's a major reason why we see these rapid changes in the polar regions, and in particular in the Arctic, where you have this sea ice cover that is now disappearing very, very quickly.
In the last few years, winters in Arctic regions have been extremely warm. In fact, at the end of February 2018, the North Pole recorded an unbelievable average temperature above zero of 2 degrees Celsius in a region used to much lower temperatures in the harsh winter. This unprecedented fact is clearly connected to a progressive warming trend observed in the last years. The cycle of sea ice is about to collapse, as during winter, sea ice usually spreads all over the surface thawed during summer months, making the average sea ice surface the same year after year. And in the last decades, that surface is getting smaller and smaller. The polar regions are being affected by global warming, much more intensely than any other part of the world. The global mean temperature has risen around 1.4 degrees Celsius since 1990. However, in the Arctic and Antarctic Peninsula, it has risen more than twice. Year after year, global warming is causing a drastic reduction in the ice mass in polar regions.
Glaciers are projected to continue to lose mass, smaller glaciers all around the world, and Greenland and Antarctica.
According to NASA, the ice layer at the poles has been decreasing at the alarming rate of 13.2% per decade. In fact, the thickness of Arctic ice has decreased 40% since 1960.
If you go to areas around Antarctica where you have a major breakup of glaciers, the size almost of a country,
on 25th May 2017, the Larsen C ice shelf rift completed its path through the ice. As a consequence, a huge iceberg of 5,800 square kilometers calved away from the ice shelf. This enormous iceberg was one of the biggest ever recorded. The Greenland and Antarctic ice sheet is a massive layer of ice, more than 3 kilometers thick in certain areas, more than 100,000 years old, that has hardly changed for centuries. The situation year after year is only getting worse. Greenland's ice sheet has been decreasing at much faster rate than that forecasted some years ago.
It's clear that Greenland ice sheet is more vulnerable to warming than Antarctica sheet, simply because in Antarctica it's so cold. If you are in the coastal region, you can have -20. So even if you increase your temperature by 2 or 3 degrees C, you have no melting in Antarctica in the coastal region.
Although the ice sheet on the Antarctic continent is very stable, that of the Antarctic Peninsula in the western part of the Antarctic is much more sensitive to climate change than previously thought. The surface of the sea ice that covers the Arctic Ocean reached its lowest recorded level in September 2018, after having broken its own previous negative record in 2012.
Millions of square kilometers have disappeared, particularly at the time of the minimum, which takes place in September usually.
In the last 3 decades, more than 1 million square miles of permanent ice have vanished in the Arctic, in area equivalent to the whole surface of Norway, Sweden, and Denmark put together. In the next 30 or 40 years, the sea ice that covers the Arctic Ocean is expected to disappear completely during the summer months, which would have been unthinkable 50 years ago. The melting of the poles is altering the delicate equilibrium on the planet, which will have a huge impact on our civilization. One of the best known and most visible consequences is the rise in sea level, which will cause the disappearance of many cities around the globe, the migration of millions of people, the loss of agricultural land, etc. The rise in sea level is now a reality.
Sea level rise is an issue too, and one of the main impacts of global warming. Of course, those of us that live on the coast, and most do in the major cities of the world, are at risk from rising sea levels now.
Sea level change is really a problem for many coastal areas with a lot of inhabitants which are really vulnerable to sea level change. We know about Bangladesh, but there are many other countries around the world which are highly populated in coastal areas where sea level change, even of a few tenths of centimeters, could be a problem. And what we foresee for the end of this century is that probably at least 50 centimeter rise of sea level change, even more larger figures if we are not lucky, I would say.
Even a small rise in sea level could have catastrophic consequences for coastal habitats. In addition, when major storms make landfall, a higher sea level will cause bigger and more severe storms. Indian and Pacific islands such as the Maldives, Nauru, or Tuvalu, coral islands of very low altitude, are at risk of disappearing under the ocean. There are two reasons for this rise in sea level caused by global warming.
One is the thermal expansion of ocean itself, like all bodies, my body, buildings, when they heat up, they expand. This also happens in the ocean, and the ocean is now heating up. The second, almost as important, is melting land ice. So ice on land that melts gives a contribution to global sea level.
Since 1990, the sea level has risen around 10 centimeters, at a rate twice that of previous years. The present rate of increase is about 3 millimeters per year. However, every year it accelerates at a rate of 0.08 millimeters. The IPCC forecast is that if global warming keeps growing, leading to the unavoidable thawing of the poles, sea levels will rise between 10 and 80 centimeters by 2100.
Depending on the emissions of greenhouse gases, we will have different scenarios for global sea level rise this century. If we continue on a business as usual curve when it comes to emissions, we must expect around 60 centimeters of sea level rise globally. It could be anything between 40 centimeters and a meter. That's the most probably development on global sea level.
The temperature rise in the last 20 years has been 1.4 degrees Celsius. We know it will rise more and faster. The international community has agreed not to surpass the rise of 2 degrees Celsius, which we know will take place. That 2 degrees Celsius change is a chimera, because to date there has been no consensus on reducing CO2 emissions, which is the only solution to stopping climate change.
We have quite good evidence that 120,000 years ago, when the temperature globally was around between 2 and 3 degrees higher than today, so very close to the political level of plus 2 degrees C, we had a sea level that was between 4 and 10 meters above today's.
This is really a concern. The previous warm period was 130,000 years ago. In this previous interglacial, the climate was only 2 degrees C warmer than today, or 2 or 3, we don't know exactly, but we are sure that sea level was more than 6 meters higher than today.
What could make sea level rise definitively much more is the chance that Greenland and Antarctic will thaw. If the whole Greenland ice sheet could eventually melt, it would cause a 6 meters sea level rise.
The risk increases later if we allow the temperature increase to cross that 2 degree target, for example, because the ice sheets then might become, some of the ice sheets, the big ice sheets, the Greenland ice sheet, the Antarctic ice sheet, part of them could become unstable and actually disintegrate relatively quickly, which would add meters and meters to sea level. If Greenland melts or disintegrates, which would take a few centuries, still it would be approximately 7 meters of overall sea level increase.
And by the other hand, if the whole Antarctic ice sheet could melt, it would cause a 6 meter sea level rise.
Antarctica is now contributing to the global sea level rise. That's shown in the last IPCC report.
And if the western part of the Antarctic ice sheet, which is the most fragile, would disintegrate and melt, it would also add another 5 or 6 meters to the global sea level. And if that takes place over a few centuries, well, it would produce dramatic changes at the surface of the Earth.